Okay, so this is a screencast where I'm going to go over some more examples. These are coming from Module 2, Lesson 3. And we're going to do number 14 and number 17. All right, so 14 asks you to solve the indicated variable. In this case, we're going to solve for j. Currently, it says h minus 4 divided by j equals k. All right. And I want to solve for j. So I want, when I'm done, for the equation to say j equals something. So the first thing I'm going to do is I'm going to multiply both sides by j, because currently j is in the denominator. All right, doing that, we'll get rid of it on the left-hand side. And that means I've got h minus 4 equals k times j. So I'm just going to write it kj. And then I want j by itself. And these two are multiplied together right now. So I'm going to say divided by k divided by k. All right, and then I'm going to clean it up a little bit. And I get j equals h minus 4 divided by k. All right, we're going to move on to number 17. And it says 2/5 of the sum of z plus 1 is equal to y. And we want to solve it for z. So the first thing I'm going to do is, well, first I'm going to rewrite it. Okay. If I take this and divide by 2/5, dividing by 2/5 is the same as multiplying by 5/2. So I'm just going to go ahead and do it that way. Notice that I get 10 over 10, so all of this cancels. I just have to make sure I remember to multiply by 5/2 over here. And remember, guys, that's the same as me saying divided by 2/5. Dividing by 2/5 is the same as multiplying by 5/2. All right, so after that one step, I have z plus 1 equals y, and I could just say 5y over 2, because that's 5/2 times y. All right, and then I need to get z by itself. Right now it says z plus 1, so I'm going to subtract 1, and I'm going to subtract 1 from over here. Clean it up a little bit, and you get z equals 5y over 2, all of that, minus 1. Okay, there's another one that I want to do, and that's number 19. It's right here. I'm going to rewrite it. So it's a times the difference of n minus 3 plus 8 equals bn. And I'm solving for n. Well, notice I've got an n here, and I also have an n here, and I need to wind up with just n equals. So here is what I'm going to do. First, I'm going to do the distributive property. That's going to be an minus 3a plus 8 equals bn. Now I want to work towards getting n's all by themselves and everything else moved to the other side. So what I'm going to do next is I'm going to take this term here, which has an n, and I'm going to move it over here so that it's on the same side of the equal sign as the other term that contains n. So here we go. Minus an minus an. Because remember, to move an entire term, you're doing that just using addition and subtraction. I get negative 3a plus 8 equals bn n minus a n. Now, if I'm really on top of things, I next notice that both of these terms have a common factor, and that common factor is n. So it's kind of like I'm going to undo the distributive property, okay? So I'm going to take an n from each term. What does that leave me here? That leaves me with a b. What does that leave me here? That leaves me with a negative a. All right. So I just basically did the distributive property in reverse. And notice, if I redid it, I would wind up with n times b minus a times n, okay? So I'd wind up with what I started with. All right, next, I need to get n by itself. This says that n is multiplied by all of this in parentheses. So I have two factors here. I have n, and I have this factor, which is b minus a. So I'm going to divide by that second factor, b minus a. Divide by b minus a. And when you do that, you finally get n all by itself. Clean it up a little bit. N is equal to negative 3a plus 8 divided by b minus a. And you probably don't really need those parentheses anymore. But there it is. That's probably one of the more challenging ones on there. You just really have to pay attention. Whatever you do to one side, you've got to do the other. Move entire terms by addition and subtraction. And on this one in particular, I had to do the distributive property here, move some things around, and then basically undo the distributive property here to get n isolated.